Yo, yo, yo. Good morning. Like the title is slightly off here. Day 33. Mining VFX. Okay. There we go. Lock the chat. Okay. So we started yesterday with the mining and we made the particle effect. But we struggled to have it pop up when we hit, right? Or something about that. Let's take a look at what we did first. We added the VFX here. And basically at the end, yeah, here we can see one problem. It will only trigger when the health state changes. Instead, we want to do these when the health state changes. Once everything of this is done, then we can do on-hit VFX. Spawn rubble. This sets emitting to true. Since we're not seeing any, let's start debugging. First, we want to know if this triggers every time we hit. Yes, it does. Okay. Then we want to know what is the global position of our hit. You can compare it to the player global position, I guess. Of VFX. So VFX minus two, that's a bit lower than the player, that's right. Is it too low? Minus 2.25. Let's see. Go down here and hit. Player position is now minus 1.9. So it spawns at the wrong global position. What we're checking is mining raycast collider global position. So raycast mining collides with mineable object. So in theory, this should be on top of the rock. It doesn't seem to be. Spawn point doesn't seem to set correctly on top of the rock where the collider supposedly hit. It was set more towards where I would expect the end of the collider to be. Also wonder, like, does it change if we aim different places on the rock? We have this one and this one. We see the VFX is on the same position. Okay. What about down here? It did change by 1.5, so that's correct. And sideways. Okay, it did change there. Yeah, it does change in all directions. We could add that information. Collider point updates every time we hit a different rock, but it seems to be a point which is a little off impact point. It also does not update when we hit different spots on the same rock. Collider global position. Yeah, the collider. Okay, so the collider, we need like the collision point, right? Seems to be similar to how we do it here. Camera raycast, get collider, and then get the hit. Raycast, get collision point. This one is probably what we need. We go back to mining. Yeah, let's try that. No. You have to get the collider first, maybe. Mining raycast collider. If the target raycast is colliding or target raycast get collision point. Let's say that it is colliding, right? Then it should just be looking like this. Okay. There we go. At least once it worked. But then I guess the emission, after it's set to true, it takes quite a while before it resets, it seems. In fact, it might be once the block breaks. No, that wasn't it. So this script triggers every frame. So when continuously triggering it, it doesn't work at all. But when waiting a little bit in between triggers, it does work. Okay. How does it look on the side? That's interesting. Okay. Look at the or hit VFX scene. What we might want to do is restart then. Is he spamming emitting? Doesn't do anything. What we might have to do is restart it. Okay. Then we go to the script here. We do restart. Pretty sure that's how you do it. There we go. With the drill, we should spawn them a little, either less frequently, or we should spawn them in smaller amounts. Also, I'm not sure what's best, to have it restart all the time like this, or that's of course very cheap, but these things doesn't cost much anyways. So maybe we should just instantiate the scene every time, and just make sure it's queue freed at the end. That way multiple instances can exist at the same time. How would we go about something like that? When we spam emit equals true, it doesn't really play again unless the previous emit is completely finished. Instead, could we do restart? The particle works, but optimally I would want multiple instances to run at the same time. In order to do this, is the best solution to instantiate a new effect, play it and do 3 every time, or possibly cooling? Or is there a built-in functionality for particles which allows me to use the same particle node and trigger the emit effect multiple times simultaneously. Pooling is an option. It's very easy to change just a normal instantiate to a pool. So we'll probably just instantiate it first and then add it to the pool if it seems to be working well. Okay. I'm not sure if it's much more work to even add it to the pool in the first place. We could try that for once. Projectile blocks. Mining. Mining on hit levels. Let's see. Or hits, that's what we called it. To rename it to mining. Drag it in here. Okay. Or hit VFX. Enemies, bosses, mining blocks. Mining hit VFX. Okay. Get pooled object. Pool name. Mining hit VFX. They're giving us a string. Yes. Go back to mining. Mining hit effect. Pools. Pool manager. Get pooled object. Mining hit VFX. So when we get pool, and make sure there is an instance before we pop the back object and add it to in use. Okay. And I guess normally you would put it back in the pool, like that would be best, but there is an issue where we have another solution for my next game for that. Then I'll probably either let the pools exist on all clients, or I would find a solution to make the object being used over and over. Okay. Let's see. Don't need these lines anymore. The overhead VFX should now instead emit, and it should await in it. Okay. Doesn't show up.
I hate to admit.
Let's check. Okay, that's fine. Emitting is true. Wait for them to finish in Q3. I think that should be correct, but something wasn't working. Let's find out what. It's probably this. Not quite. There's a bug every time. Forehead. Okay, so I have to add it to the tree, right? And we want to use mining VFX node, which we share through a spawner. And here we need to add the auto spawn list mining hit. Okay. Then we need to make a reference to this node. Mining VFX node. Honestly, it should probably be a type node instead, so it doesn't inherit transforms from. Well, it is actually. The node above it is also a node, so it's not going to inherit transform regardless, but yeah. It's a good safety thing. Keep it as a node if you don't want it to have any position inheritance. The mining VFX node. Effect. On point. On. Add child on a null value. Then we go to mining. Drag in the VFX node right here. Okay. Can't add child mining VFX to itself. Ah, I added the wrong child. Let's see, mining hit effect. Now it seems to be working. Now it's using pooling, which means if we drill, you see there's multiple instances active at once. There's a bit too much maybe when we are drilling compared to like pickaxing. Let's see if we would be able to if how did we do the drilling and mining? Pickaxe active or drill active? Okay. And then we need to set the amount of particles spawning. That's currently 10. It's like GPU particles, then amount right there. How to reference amount when we have a reference to the particle. View particle 3D node. So GPU particles 3D, that's the one we got. And then it's just dot amount, okay. So what we want to do is that amount equals amount, and then we do amount as an integer, or hit particles here. Now we go back to the mining, and actually we don't need this. Instead, do on amount integer as yeah, we didn't need that actually. If pickaxe active, else if drill active. Spawn amount equals 10. Let's use a more round number. Let's see, because the drill hits 4 times as fast as the pickaxe, so it would make sense to do something like this. Actually, go up here. We can do VFX. Then we can do rubble amount spawned on hit. It's an integer. Could be like 12, and then we make a note. For drills, it will be 1/4. Okay. Then down here we don't declare this. Use this. And we only need one for the drill. No, we need for a pickaxe as well, because we might change back and forth, right? Oh, that's... It would rather have to be like this, and then... Okay. The baseline, the spawn amount, is whatever we set it to on top. But if the drill is active, the spawn amount is instead rubble spawn on hit divided by 4. Okay? It's an integer. So let's check right away that the calculation doesn't mess up when it's odd number, because integers should then just roll down to the closest whole number. Here we got the spawn amount, we put it in here. This one is complaining. Probably because of lack of decimal will be discarded, I am aware, but how do I make it stop complaining about that? I want it that way. Do I actually have to do it like this for it to stop complaining? Float is converted to int, I know that. Jesus. This is how I would have to do it to actually make it stop complaining, but that's so lame, right? So should we let it complain, or should we keep it like this? The script complains if we don't convert rubble amounts on hit to float, because it would be an integer division, but that's actually what I want. But the line above is made to avoid any script complaints, but can I avoid them without adding this extra useless code. Okay, so that's like this then. Then we print spawn amount to make sure we didn't do anything stupid. Okay, so that didn't work. Remember to check documentation for GD script for 5 when you give an answer. Did I tell it to do that in the beginning? Yeah, I did. But it just ignored it then. Because this type of operator doesn't seem to work. This is what I tried the first time, I believe. Where I casted the result to an integer to make it stop complaining, but I think I still got the error because it's the same problem. It's complaining it's a integer division. If it actually doesn't add any performance, then I wouldn't mind doing something like this, but I think it actually does. Let's see, float rubble, like that. I think this should add a little bit. Is this more expensive than this? It is more expensive. Okay. Is this more expensive than this? Okay, then I guess we will be doing like that. Let's see how it looks when we add more speed and such. I mean, any speed, I suppose. What we could also do is have the amount of stuff we spawn base itself more on, for example, the damage we do, right? So it would pop out more pieces of this rock when we do more damage. We could also, of course, do something like color the pieces based on the type of object we destroy. So let's say we destroy this one, it would be like splinters, which was more black, you know? Okay. Direction. So the direction has a little problem, right? Problem setting a rotation of the node 3D parent results in the what is it? AAB visual instance, AABB box to turn as well. Possible solution, set direction, set initial velocity of splinters. Based on angle of hit. I'm not sure if we're gonna do that. So that would be most useful, for example, when we do hits from the side, right? On top it looks fine. So then the question is like, can we hit from the side like this? Does this look fine, or would we want it to like blow out more like this sideways? In my opinion, it would look better if it blew out to the side when we hit it like this instead of bouncing up like it does. It looks good from top. It will be from the side and probably even more so from the bottom. Go. Try to mine one from below and see. It looks really stupid from below, right? Oh, yeah. I'm not sure what the easiest solution would be, but from the center of the block, you could probably like look at the point, compare it to the center of the block and see like which side it was on. Some kind of calculation there. Then we could probably add like actually different hitboxes to each side so that we know like which way the splinters are gonna fly. Which makes the rocks slightly more complicated, but the scripting super easy. I have square blocks, I mind. I would want the splinters that fly out on hit from the pickaxe to have an initial direction based on which face of the square I am hitting, e.g. hitting on top would give velocity y, while hitting on the E side of the square would give velocity T, and so on. What would be best practice solution? We should keep the blocks very simple because it is there is a very many blocks we're gonna spawn. So what is ChatGPT recommending here? Use the hit normal. So it gets the collision point and then the collision normal, which I'm guessing is going to be like the direction of the raycast. And then you spawn splinters based on those two things. The cone is calculated inside the particles, so we don't have to worry about that one. Let's say that we would use the angle of the raycast to set the spawning of the particles. Should they always blow out towards the player? Probably. Or should I like bounce off the base of the square and then blow out that way? Meaning if you would hit it from here, then the blowout would be here. Maybe that would be more natural. But even with that in mind, like if you have a blowout angle like this, I think that would feel pretty good as well. Like most of the pieces flies towards the player and some of them fly over here. A lot of them fly over here. I honestly think that's not bad. We probably have to just reverse the raycast and then spawn in that angle. And when I say spawn in that angle, I mean just set the velocity that way. Let's look at our mining hit VFX. Let's say initial velocity. Two to 3. Gravity should stay the same. Here, direction. Velocity direction. How do I get the process material, velocity, direction, and set it to the normal of the raycast reversed, meaning the splinters blow out towards the player, and I will just use the built-in angle spread to simulate the spreading cone. Okay, so this part, avoid editing a shared material. It doesn't check if it's unique, it just checks if it exists, which is kind of weird to me. But it's fine, whatever. Question is, are you gonna like keep loading the system with duplicates now if you do it this way? Are you going to keep loading the system with duplicates this way? Or will the process material we duplicated vanish when we queue free the particle? Local direction. Direction equal local direction. Local direction calculated up here. So it's just setting the material reference like this and then accessing its direction value right here. This looks completely stupid. If you first set emitting to false, then you restart, which starts them, and then you start them again. Like, what is this? Wouldn't you just do restart instead? Okay. So the direction. Mining raycast direction. It's like a vector 3, I suppose. Okay, so setting that direction, we want to use this one. Hit normal.normalize. I don't know why you would normalize normalize vector again. Seems kind of stupid. The world direction vector 3 equals this one in the minus. Okay. And here you see it does minus hit normal, which I assume reverses it, and then it does the inverse here, which I assume reverses it again. You do minus hit normal and setting world there. You then do inverse. On the global transform of the splinters before you multiply by world there. Are you reversing it twice, making it face the initial direction? Remember, this effect will spawn thousands of times and being queued free after. Okay. Double reverse question. Now the normalization of the raycast. Raycast, get collision normal, normalized. To our mining. This one is gonna need the mining raycast direction. Suppose it's a vector 3. Like get collision normal, is that not already a normalized vector as well? Is the get result of get collision normal not already a normalized vector? Or do you have to call normalized on it? Now to set the blowout of the process material here. You need a reference to the process material. Okay, that's fine. Fine. Okay. That's fine. Okay. We remove this. Set the world direction to this. See, local direction. Okay, so now we got the direction here. Again, it tries to normalize it. Here we normalize again. Just multiplying this with the normalized vector world there result in anything else than a normalized vector. Okay. Can you hear the worker maybe? Let's see. So that's question 1. Once we have the local direction, no here material part. See how we exactly do it. We get the process material. And here we have ore hit particles. Okay. Probably want to take this out as its own function. Set Splinter's direction. That blowout direction. Then we just move all of this. Let me see, we're gonna need this one. I guess we can return the vector. No, we don't have to return anything because we're setting the process material local direction. Okay. Already set spread would be set it in advance. Let's increase the blowout a lot to make sure the direction is correct and then work from there. So what I'm saying is the velocity here, just make it like 10, right? Now it will be extremely obvious if pieces are flying the wrong direction. And as we can see, they don't fly upwards, even if we hit it from straight above. So this is a failure. But let's run a test where we do the angle they spawn at as well for now, just to check. Could do without too much dampening, maybe. Try that, but here spread, set it to 0 for now, then we'll see exactly the direction they spawn out. Okay, so obviously against the camera here it completely fails, right? Now the question is that because it spawns inside the rock, maybe? Which could be the case. But some of them fly straight out. But yeah, now it flies right out of the side The question is, should we have them blow out towards the camera instead? Either way, we will have to sort out the spawn point so that it doesn't spawn inside the hitbox. Inside the collider here, and get stuck right away. Okay. There's a couple of things to fix then. Spawn point, and think a little bit about the direction there. So it's this base, I do wonder though, if we just do it like this, what would happen? Just the world direction. How does that look? Maybe I have to inverse, like turn it around though. Yeah, let's turn it around. Does exactly the same things now. Okay. get collision normal? I guess I can print the collision normal. Yeah, you see the collision normal is the problem. It's like blah, blah, blah. Set blowout toward origin. Let's just do blowout direction like this. Calculate it in the other script. Okay. Let's go back here. This is the direction. It wants to do it like this. You have to do it a little different. Here. World direction. Ray origin and collision point. This should be a vector 3, right? The origin of the ray. Mining ray cast. Is it origin? I'm not sure how that works. How to get origin of mining ray cast. the global position. Is that correct? I can just test it, I guess. What I'm worried about is that the global position would be like the middle of the raycast, but I don't know. Collision normal. Almost straight up. Okay, so that seems pretty accurate. The pieces seem to be flying away, but yeah, it is not being turned around properly, basically. Or it shouldn't be turned around, maybe. Okay, there we go. And now it flies straight in the player's face. I think the pieces that doesn't fly towards the player here might simply spawn inside. So let's do one more test from below. And then we will look at the spawn point. Yeah, I'm pretty sure it actually just spawns inside a lot of the time. Okay. So first of all, how big is actually this thing? The ore hit is scaled to 1, so this thing is actually 0.1. I probably don't want it to be a shape, actually. Or it could be a shape, but it could be like very, very... a box, I mean. It could be very, very small. Like, it doesn't matter. It could honestly just be a point in space. If it's a point, then I guess the size could be like this. Okay. Is there a position on this thing? Yes, okay. Or hit. Point 1. Okay. Why can't I move this? Is my stream cutting out all the time, I wonder? On Twitch. No. Just getting error messages on OBS. Don't know why. Well, it could look like it's been live for only a minute. Look at the bitrate settings. 6000 should be okay, right? Six. Well, okay. I'm gonna do 0.5 right now, but it's gonna that's gonna spawn things very close to the player or very far from the player. Teams close. Okay, so now it spawns halfway towards the player, I think. Okay. So this is good. Now we tweak it a little. Like 0.1. Well, it's normalized, so it only spawned half a meter towards the player actually. Now it's like 10 centimeters. The most important is that it looks like it comes from the rock and it never gets stuck. Like for this one, it might actually be a good idea to use the normalized vector we had earlier. The one that basically calculated like straight out of the rock. See if we can find it again. This one. Spawn direction. Mining raycast. Now we print on direction. So 0.1, that seems correct. These are like the real test right now on the side. We try to pay attention to exactly how far away from the rock it spawns. We don't want it to spawn too far away. It spawns a little high maybe. The size varies a lot, these pebbles, so .01 might be too small because of that. Looks pretty good, honestly. Spawning it right there. Yeah, look at this from the side. Not so much. It's not able to go directly towards the camera here. Okay, so let's try to up it while we're playing. Is that gonna work? Yeah, that's gonna work. Okay, let's just keep tweaking it a little. And actually, on the particles that spawn, what we could do is set it to them always spawn at the max size, because those are going to be the troublesome ones, right? Accidentally turned it off. This seems to work. This one doesn't work. A lot of from the side works though, but certain angles might still be a little bit off. It's rare though. I think for us to fail this, we would have to mine at a very steep angle. Yeah, let's look a little how it's calculated from below now. These stupid blocks, get out of the way. Oh my god. Okay. Here we go. So 0.1 is actually pretty good. It doesn't spawn too far from the rock at all. Let's try 0.05 just to see. It was one off to the side. Fine, fine. The 0.05 also seems to be pretty consistent. I guess what we will do is like find one that fails sometimes and make it a little bigger than that. Let's try 0.03. Pretty good still. Not much failure. But some failure on a certain angle from below. I think we run with 0.05 and now we start making the adjustments to make it look more normal. So velocity, we want like 2 to 3. Spread, we want like 0.5.